Let me share the PPT. I hope guys you can see my PPT, right?
Yes.
Yeah. Yeah. So guys, in last session, we talk about different aspect of data warehouse, right? We build a data warehouse, data lake and RDB mesh system. In some of the cases, we stage data into RDB mesh, right? From let's say storage account to database, right? And we also populate data into the data lake, wherein we sometimes ingest data from the, let's say, API, REST API, and transform it with the help of ADF pipelines, right? And load into the data lake, into data lake, and data warehouse house as well, right? We did the same thing. We upload a couple of files into our, let's say, storage account, and those data, incremental data ingestion, we did into the data warehouse system, right? So those all things we have seen in earlier section, right? So I just wanted to, before moving, I just wanted to take you through is that what is the difference between these systems, right? Okay, just give me a second. Let me make it in presentable mode here. Now, guys, if you see here, first of all, definition, right? The definition wise, what is different between RDBMS, data lake, and data warehouse, right? First of all, in database, you have the structured data. You have the structured data wherein the fixed schema, right? And there is a constraint between different tables that you have there in databases, right? First, let's focus on the what are all the things in RDBMS. Let me take a marker. Okay, so data is, yeah, it's a structured schema, right? And all the tables are mapped with each other with the help of primary key, foreign key constraint, and there is relation between tables, right? One to one, one to many, right? That's what the RDBMS database, right? Data is structured only, and some of the example are like MySQL, Postgres, and Oracle. These are the example of RDBMS system. Now, when it comes to the cost guys, its cost goes to the medium to high, right? It completely depend on your usage. If you scale up your database with a very high compute, right? And of course, the storage is still fine. Storage won't cost you that much. But if you scale up your cluster very basically compute very high, then you will get a more cost. And the performance wise, of course, if you need a transactional data, right? Let's say some banking transaction you are doing, and the moment you, let's say, credit some amount to next person account, that you wanted to get notification and on that moment itself, right? So for this sort of transactional things, data RDBMS is always preferred use case, right? I talk about OLTP transaction, online transactional processing. So what is the transaction you are doing in day-to-day operations, right? In that cases, you buy something, right, from any shopping provider, right, e-commerce system. So all these things need some transactional database. You want the moment you, let's say, do some credit action, debit action, or credit action, you wanted to get notification of that, right? So those are the common use cases of this thing. Language is SQL mostly, right? And schema enforcement is like schema on a write. So what's that mean, guys? Your schema should be available first. So let's say I have my database, right? And I wanted to write, let's say I have some sales table there, right? And in the sales table, if I wanted to write some data, that table should be available with the proper schema. That's what imply the schema information, the schema on the right? And now talking about the scalability part, right? It's a limited, right? Vertical scale, because it's like if you need to make thing very, let's say you are getting the huge transaction, right? Huge volume of data, then you can scale up it vertically, but there is limit to scale the things vertically, right? So that was some of the pro, and basically I would say the definitions of RDBMS, right? What's the meaning of RDBMS, right? Now, in earlier session, we even covered this data lake aspect, wherein we store data from all the different system. I told like data lake is like you have structured, semi-structured, unstructured data. What is structured data? Your databases, right? You can literally export your entire data from RDBMS system into data lake. Maybe you need that to be exported in the form of CSV or some analytics, right? So you can store your structured data, semi-structured data, your log files, right? Your whatever, whenever you are deploying any application, guys, and it generates logs, that logs is basically semi-structured data. it have some meaning, right? Timestamp, then basically information, what is logging about, right? That sort of things it have. So it's a semi-structured data. Even the JSON, right? It's kind of do it. If I can show you some nested JSON, that's also semi-structured data. So it store the structured, semi-structured, and unstructured data as well. So what is meaning of unstructured data? Let's say you have some Word document, right? You put up, you have some video files or anything, right? So that you can upload to data lake and generate the some insight from that. So these are the, for that cases mostly people use the data lake. These are the things that we can store into the data lake. Data type I told, right? It's structure, semi-structure, unstructured. What are the common example? Amazon S3, we see now Amazon S3 example, right? And Gen 2 data lake also we see. Cost wise, it's cheap because that's how they design. And one of the good aspect in data lake, let's say you put some data. Let's talk about the S3 example. You put data into the S3, and the moment you put data into the S3, it go into the hot tier. Okay, but if you enable the intelligent tiering in S3, and that data you are not using frequently, then that data move to the basically lower tier, let's say warm tier, right? And you also have the option to move that data into the basically archives, right? So these are the couple of things that possible in S3. It's a low storage, low basically cheap in term of cost. Okay, slower for query because it's not meant for high query performance, right? You can query the data in, let's say you have, let's say CSV file, right? And you can query the CSV file which is available in S3 with the help of some tools and all. We will cover those in upcoming session. So that's also possible. But it's not meant for, this data lake is not meant for querying. If you wanted to query something and you want the result to get very quickly, so not data lake is the right choice for that. Now use cases, mostly you ingest data, everything that, okay, you want that this data can be something maybe useful for me, for my organization, and that could be helpful for me to generate some insight. Then in that case, people use this data lake. They dump data from, let's say, multiple domain. Let's say one company, they have one finance domain, HR domain, right? And they want, in each data is having their own truth, right? Let's say finance data, sales data, HR data. But if we combine all data into the centralized place, we will get the single source of truth, right? So that's how a company build. They the multiple domain that organization have, they club all the data into the single place so that they can generate the single source of truth from that particular location. So that's how people generally do, right? Some of the examples like basically Hive and basic and Pesto as well is one of the things that the basically when it comes to the query, right? You can, whatever data you store into the data lake, you can connect to that data lake via Spark. Okay, you can, earlier in one of the example we even seen, right? With the help of Spark, we connect to the CSV file stored into the data lake, we process it. Same for Hive as well. Hive is a file system. You can query the data which is there into data lake, S3 data lake, with the help of Hive wrapper on top of that and Pesto. So these are the few things. It's a schema on a read, guys. So let's say when you are loading some, let's say for example, I'm giving you one of the example. Like, okay, I upload some data into the data lake, right? And that particular I upload, let's say 10 rows, and that 10 rows having, let's say, 10 specific column, of course, right? Now let's say I'm inserting the 11th to 20 row with two more column, right? Let's say I added two more column into my next upload. So it will not constant, it will just load whatever things it have, right? And at the time of read, now let's say if you read data via, let's say Spark, you will see 10 row having the 10 column, and next, let's say 10 row is having the 12 column, right? So that's what they define a schema on a read, not on a write. So that's one of the different, guys. And until is scaling, right? It's scalable, right? S3 having 99.11 time 9 availability, right? So and you can scale up horizontally. It's like you can literally there is no constraint when it comes to the storage on data lake. Only thing that you need to pay the cost accordingly, but it's a highly scalable. Now the guys, data warehouse. We talk, right? Data RDBMS is fine for single thing, right? Transitional data lake for structure, semi-structure. What is the purpose of data warehouses? All right. So let's say you have multiple databases. Database, let's say you have 10 databases, right? Let's say database for HR, finance, and other organization, other domains in your organization. Now you wanted to, and these are all the relational database, right? There is no unstructured data. It's just structured data into this database. Now, what people want, all the data which because data grows over time, right? This year you have data, then again second year data grows, right? Maybe after 10 years you will be having more data. But do you think, guys, 10-year data, maybe let's say if there is a cutoff, I want my data which is post 5 years, maybe I wanted to not even 5 years, whatever data I have, right? I wanted to move that data into data warehouse, right? So that my current database should focus on current, let's say mostly current years, let's say a cutoff of 5 years, right? But my all the data from 5 years to older years, right? Let's say 20 years, we can store into the data warehouses. And then it's a centralized repository of structured data. All the data from different databases we can store into the data warehouse and generate some meaningful insight from that. So from here also we are generating insight, and here also, but difference is in data warehouse you have only structured data, right, guys? And a few of the example are like Synapse. We talk about Synapse, right? We explained a couple of things. Amazon Redshift also one of the example in AWS. It's a highly compute because the cost is very high in this case when it comes to the cost, guys, right? Because it's an online analytic, and the way it's designed, because let's say this data having huge query, let's say 10 or 20 years of data is available in your data warehouse. So when you are querying this, the normal querying engine won't work in this case. So they need to optimize their querying part so that you can get the right result in less time. So that's why it's a highly optimized compute, right? And fast for analytics. Basically, if you wanted to do do analysis of anything, you cannot rely on 1 or 2 year of data. You need the data, let's say 5 to 10 years, right? So that at least you can generate some pattern out of it, right? Getting some meaningful insight. So mostly used for analytic purpose. As I mentioned, it's OLAP, online analytics processing. Its mainly purpose is for reporting dashboard, because the C-level people, right, basically in organization, the people which at a high level hierarchy, right, they wanted to see the reports dashboard on their current 5 year data, right, 10 years data, so that they can take their business decision accordingly. What should we do in terms of next strategy and all right. So reporting purpose people mostly use. Of course, SQL is a choice to run the query on this data, and this is also schema on right, guys. So you should have fixed schema ready so that you can then only you will be able to load data. Otherwise, you won't be able to load your data, right? So that's what schema enforcement here. And then scalability part. It's a moderate to high. Now it's come to like, see, if you create a data warehouse and not having huge data, of course you will get sorry. So when it comes to scalability part, moderate to high. So what's that mean, guys? It's scalable, but it depend on how you design it. So when I'm saying how you design it, let's say in Synapse, let's say data warehouse, right? How many basically DW unit you assign to that particular data warehouse, based on that it's scale. Now, if I know that my data warehouse is I need for the data warehouse, I need a very high scalability, then I need to give more DW units so that it's more scalable and it can perform well. So it's completely depend on your configuration, guys. So this is all. I just thought maybe before going to other things, you should have know about what are all the things, right? And these are all the things that we cover in earlier section. We create database, data warehouse, and data lake. So any question, guys, before I move to the next point? Okay. And I will go to the next things if no question. Okay, let me share my draw things. So guys, now today we will talk in detail about the Spark architecture. Okay.
Okay.
We open the file new tab. Okay, guys, let me know. So I hope you can see my guys screen, this week 3 session 1 draw. So I already have some diagram ready, but if I just show you that diagram, maybe you guys may not able to understand because you are looking this first time. Maybe some of you might have already know, but if I will start from the blank, maybe I think that would be more beneficial for you guys. So what's Spark architecture, right? So before even going to direct architecture, I just wanted to show you a few things. So guys, Spark architecture we will show, but how we come to the Spark, right? It's not like directly, I think before directly jumping into the Spark architecture, we should know how things started. If you remember, I told you earlier that evolution of big data, right? How the things were before big data and how things happen after Hadoop came in picture, right? So before Hadoop, it's a morely transactional system, right? RDBMS is the only thing we were building application, right? Front end, back end, and loading data in database. That's how industry got started, right? And the way that time things was, you have, let's say, you have a piece of code, okay, which is running on some set of data, right? And since let's say you are having huge data, you need to increase the compute so that your code can process this huge data. Of course, when you are running code, it needs memory, right? And if you have huge data, then it would affect memory. Right, so that's why you need to increase your memory so that your piece of code can process that huge data and do the rest of the processing. Post Hadoop, what happened? It's a distributed computation happen. Post Hadoop, we call it a distributed computation system. Files also got distributed and code also got distributed. What is the meaning of that? When you in HDFS, when you upload any file, right, it stores that data files in the form of partitions, small partitions, right? And when you wanted to run code on top of that file, let's say you are having file of 5 GB, it get partition into, let's say, for example, 120 MB of partition size. That way maybe almost 40 plus partition you will create, right? That file will create. Now when you run your piece of code on that file, what this code would do, this code, the piece of code will go to the each and every partition, process it, and give the result back to the your centralized system, right? I will talk in detail what the centralized system and all. So that's the main major change happen when it comes to the distributed system post Hadoop, right? Now what's Spark? With Spark, what happened, guys? Hadoop was good, but it was doing much IO job, reading from the disk, right? Do shuffle, write temporary storage into the disk, right? Get some more data. So IO is 100 time. So in memory computation is, guys, 100 time faster than IO, and that's where Spark changed the game. Basically, Spark did entire thing in memory. So whatever your data processing is happening, there is no IO unless until you explicitly specify it, right? And with the help of that thing, Spark got more basically demand because it could able to process the huge data in very less time. So that's how the things in a Spark come, guys. Okay. Fine. Now, guys, I will just maybe, so how Spark, right? I am talking about that. Okay. Spark did these things. Okay. Now, and it process data very fast. But first of all, to make your thing run on a Spark, okay, a Spark based cluster, you need to create some cluster, right? So that you can process your piece of code over there. So now let's go to the Spark architecture. Okay. So for any, let's say, if in Spark architecture, guys, you need a piece of, let's say, VMs. Okay, you need a multiple VM. That VM could be of EC2 type or Azure VM, right? And based on your requirement, let's say you need a high compute VM, right? Then you can choose a respective or high memory optimized, right? Then you can choose, these are the all the series of VMs from the respective cloud provider. Storage optimized there, and high performance also VMs are there, right? So based on your use cases, you will create a set of VMs, okay, and form the cluster out of it. So let's say we can imagine that, okay, we will choose any one cloud provider and we'll build one cluster now on Draio. So let me go to Draio skin. Okay. I hope, guys, you can see my week 3 session 1 things. Okay. Now let's take, yeah. Sure. Okay, now let's say, first of all, what is VM, or basically what is a cluster? So cluster is nothing but the sets of VM. Okay, you will create the multiple VMs. Okay. Now guys, what I'm doing over here, I'm creating the cluster of 10 node. VM is nothing but the node. Okay, what is a cluster, guys? Now let's say each VM is having some capacity. Okay, okay. So what I will do, I will maybe copy things from other end so that we can spend that type more on understanding rather than typing things. Okay, so each VM is having 100 GB of RAM, okay, and 20 cores and 400 GB storage. What is a cores? It's nothing but a parallel processing unit, right? If you have, let's say, 20 cores, you can run the 20 processes parallel. Okay, so my each VM is, let's say, 100 GB of RAM, 20, and each VM is having 20 cores, and each VM is having 40 GB storage. Okay, now if I talk that way, this way, what could be my cluster size, guys?
It will be GB into number of node.
Right, excellent. So see, the cluster size is, you have 10 VM, right? And 10 into whatever the number of GB, right? And cores and storage. So this is what your cluster size would be, guys, right? Now, okay, imagine that cluster is created. Now in cluster, each in each cluster, right? You have some master and worker node concept. What is the purpose of that? Because in cluster, there is some one orchestrator who know detail about each and every node in a cluster. Okay, so this is master node and he knows each detail of each and every node in a cluster. So so though network team would help you in designing those things, but at least you need to know those concepts. This is our master node, right? And these are all the your worker node basically. I will just denote one worker node, right? So these are all your worker nodes. Okay, now you set up your entire cluster. Now what's next, guys? You need to run your Spark job, right? You need to install some software in this cluster so that you can run your Spark command and all these things. So what are all the things we need to install? So let's go there. As you see in my PPT, in Spark cluster, what is YAN? Okay, Spark cluster with YAN is nothing but yet another resource negotiator. What is the meaning of it? Basically, it's the cluster manager. And I told you, right, there is a one master and there are workers. So this, with the help of YAN, it create one resource manager and node manager in your cluster so that resource manager know in detail what are all the things are available in terms of compute and storage, right, in my cluster. So let's say we have cluster ready. So now to let that cluster know the Spark and other thing, right? You need to install these softwares. Let's say Java SDK, right? So JDK, right? Basically, because it's a Spark and YAN based dependency, because Spark and YAN indirectly need the JVM dependency. That's why you need to install Java. Then Apache Hadoop, YAN resource manager will be, I will talk what's on YAN resource manager, right? And then Apache Spark. Of course, since you need to run a Spark programming, you should have the Apache Spark installed. Then YAN, right? YAN also one of the software that you need to install. It's a cluster resource manager, right? And then the Python, of course. If you want to run Spark job, you will install the Python there, right? So after installing all this software, guys, you will having one master node and worker node in your cluster. So our what was the master that we have created earlier, that we will call as a master node now, and then there will be worker nodes, right? So this master node is nothing but the yarn resource manager. What is the purpose of yarn resource manager? It allocate the resources to your, basically basically when you submit a job, right, it allocate the resources to that job. That's the job of yarn resource manager. It know how much compute and storage I have in my cluster, right? So that's the yarn resource manager. And what are all the worker node? These are nothing but a worker machine, and these are, we in yarn we call these as a node manager. Okay, this manager will actually execute your code. Now post this installation, guys, your cluster would change like this master would act as a manager, and these worker would act as a node manager, right? So you will be having these multiple node manager now in your, so cluster. Okay, guys. Now that's fine. We have cluster ready. Now we need to submit some Spark job, right? And other detail. So let me go to the next step now. Okay. Now our Spark cluster is ready. Now let's say one user come and he wanted to submit some Spark job. Okay. How that Spark job would look like and all, I will just paste over here. Let me move things. Okay. Now I will explain these things. Okay. So what is Spark job, guys, right? It's nothing but the Spark submit command. I will show you in later stage. Okay. It's nothing but, okay, you wanted to run, this is my example. Okay. I wanted to run. Okay. And if I wanted to run this piece of example in Spark cluster, this is how with the yarn setup, this is how I need to submit my Spark submit command. I will do the Spark submit. Okay, yarn is my basically resource manager over here. Deploy mode is a cluster. I will talk detail maybe what is deploy mode in later, but just to give what is deploy mode, when you there are two modes, client mode and deploy mode. When you run the Spark job in deploy mode, it execute all the things in this cluster. So it execute all your processing in this cluster. But if you if you execute in client mode, your driver would, your main application would run over here, and all the other processing would happen over here, right? So that's the main difference, guys. We'll cover in detail. Maybe when I will go, you will get more sense out of it. But just you should know that each and every line what is coming over here. That's why I just quickly brief you. So in cluster mode, you will be having entire execution in these places, right? And in client mode, you will be having your driver running over here and all the executor running over here. That's the only difference, right? And then driver memory, how much memory you need, right? In the driver, num executors, number of executor you need, right? Executor memory, how much executor, and executor cores. So all this information you need to give, guys, whenever you are running any Spark job. Okay. So what is talking? Driver memory. So it's saying that when I'm submitting Spark job, there is one concept of driver. I need that driver to be have 20 GB of memory. Okay. Then how much executor I need? These nodes are nothing but the executors. Okay, you can have multiple executor in node, but in our case, for simplicity, we will consider one node as the one executor. So I need 4 executor, for example. I need, let's say, 4 executor, 1, 2, 3, 4, whatever I will pick, right? Now in each executor, how much memory I need? I need a 10 GB of memory. That's what I am saying, that okay, I need a 4 executor, and each one, in each of the 4 I need this much of memory, 10 GB of memory in each. And how much cores? I need a 12 core in each of the node manager. Fine. And this is how I will instruct my resource manager right? I will submit this command with this Spark submit, and we'll give the name of example pi. What is the example pi, guys? It's very simple. I'm creating Spark session out of it first of all. Okay, in first line, once my session got created, what I'm doing, I am reading the file which is available in some location, let's say in cluster. Okay, I got that file. Now on that file, I am applying some transformation. What I'm doing, I'm just selecting few columns and applying filter, right? I need the salary greater than 50,000, right? Fine. Now, then I am doing the, once I got the salary greater than 50,000, on top of that, I am doing another white transformation. We'll talk what is not narrow and white, but you just think about it as of now. I'm applying some filter, and then on top of that filter, I am doing group by and taking average, let's say average salary as a output. Okay, so this is what my simple piece of code. It can be anything. I just give you one example for this one to explain narrow and white transformation, but it could be anything, right? So what is narrow transformation, guys? When you, let's say you have one data available, right, and you apply some filter, right, or you just select data. So these are generally people, these are people call these, so or let's say selecting only a limited column, right? So this sort of transaction people call as a narrow transformation, because you are just applying filter on top of that data. You are not doing anything apart from that, right? What is white transformation, guys? When you do group by, right, or repartition, then data got shuffled, right? And people call that as a white transformation. I will talk in detail how that happened internally, but just to let you know why I have written this wide and narrow transformation. So apply, I have some Python file and I will run this Python piece of code, right? And this is what output, this is what my CSV file look like, guys, right? And size of my, let's say CSV file is 5 GB. Fine, clear. Now, one more thing I wanted to tell. Right. So guys, I have 5 GB of file, right? So if you talk that way, generally in cluster, when you are having any file, it divide that into the partition of 128 MB. So this file is having, let's say 40 partitions, right? So I have now 5 GB of file, and it is having a 40 partition. Now what happened, guys? When you submit any Spark job, so now let's say you as a user, you submit Spark job. So first of all, this Spark job would go to the resource manager. Okay. Now resource manager, what it do? It look, okay, I got one Spark job, and it asks these things. Okay, it need a driver of 20 GB memory, right? And all these things. But resource manager is only concerned with a driver memory. So what resource manager do? It will create one container process in any one of the node manager. What is a container? A container nothing but is a JVM process, right? Because it need to run some this piece of code, right? So it will create a container. So let's say we'll call this as a container, just as a legend. Okay, and it will create one container over here. Let's say any one of the VM it can create. It will just see, okay, does this VM is having 20 GB of memory available? If it is, then it will create that container over here, right? So it's container created. Now what this would do? Okay, it create the container. Now what's next thing? This container start would look into this piece of code. Okay, so it look, okay, I need to run this piece of code, okay, with these many resources. Like I need a number of executor 4, right? And then executor memory for each VM is 10 GB, executor core is 12, and this is my example pi, right? So what it do, because it don't know where that memory is available, then it again talk to your resource pool. Okay, this particular job which I got, it need this memory. Tell me, and it asking 4 executors. Tell me where I can get these 4 executor. So resource manager, I told you, right? He know each and every detail about your cluster. So it tell your this process container, which is nothing but the dry up application master. Okay, so this process which first of all get launched, that they call it as application master. So driver no, okay, sorry, application master no, okay, sorry, application master talk to resource manager, and resource manager now tell him that okay, these are all the 4 executors that you can use. So let me highlight those 4 executors with some different color. Okay, so they got a, let's say, green signal for these 4 executors to use. Okay, so resource manager told that okay, these are all the 4 executors that you can use for your processing. Okay, now what application master would do? This application master is also in cluster mode, guys. So because we are running this job in a cluster mode, this application master is nothing but a driver in this process. What it do? Then it create the containers in these processes. Okay, so I think Rameshwar, you have written something by mistake, possibly.
Yeah, sir.
Okay, nice.
How can I undo that?
Sorry, just checking. 1 second. Let me just take that eraser. Got it. Yeah, okay. Now it create this, guys. Basically, resource manager, application master talk to resource manager, and resource manager told, okay, these are all the VMs that you can use. Basically, core executor. These are all the executors that you can use, right? And what this, and then your driver. Sorry, let me just. Okay. Now this application master is nothing but a driver in this case, guys, right? I told you. So this in cluster mode, your application master also would act as a driver. What this driver would do? Now this driver would launch the container process in each of these VM. Okay. So container is nothing but a JVM process, guys. So it would launch one container over here, one container over here. So guys, from interview perspective, this is a people mostly spend time on this thing. So I think you should know each and everything. Okay, that's why I'm going in more detail. So it will create a container in each of the VM, right? And what it do in each VM, right? In each container, it give 10 GB of memory and 12 cores. That's what we ask, right? 10 GB memory and 12 cores. So each one will get the same allocation, right? Okay, now it got that thing. Now one more thing I want to talk, guys. When you first of all launch job, resource manager talk to, let's say, one of the node manager, and it create a container process, right? If you think, guys, Spark is written on a Scala, okay? But container is a JVM process. And if anyone is familiar with the JVM and those things, in JVM you need some main method, public static void main, right? Main method to execute your program. How it will get? Because you have written code in a Spark, sorry, basically PySpark in this case, right? So what Spark developer did, they create a wrapper on top of a wrapper, basically the Java wrapper. Okay, what that wrapper do? It convert your piece of code in a such way that it would get the main method and it can execute. Post it got main method, then only it can understand entire thing, and then only it can launch all these processes, all these container across different location in your cluster based on resource availability, right? So this is how it would work internally. Fine. Now it create the basically 4 containers. Okay. It told that, okay, I have this data, I have resources available over here. And it's now basically driver would told, okay, launch these processes over here. Okay, and this application master and driver is nothing but the same thing. Now what happened, guys? These executors, these are all the executor would start processing this data. Now what is the file that you have, right? This file you might have placed anywhere, right? In this cluster, when you are uploading, let's say you have one cluster and you upload file, right? It don't tell you, okay, I'll uploaded file in this node and this node. For user, from user end, you just upload file, but cluster manage where that file could be, right? So file can get placed in any node. It can get placed in this node, in anywhere, right? Or enter this node. That's completely depend on the your storage and computer, all these things, right? So let's say file we store. Now what happened, guys? When you are running this piece of code, right? First line, what Spark do? Maybe your file could be here, or maybe 4 places. Let's say in our case, we imagine my file is in these 4 places. Okay, whatever file I have uploaded earlier. Of course, before reading, I need to upload file, right? What Spark do? It read the file from all this location into in memory. Okay, and after reading it, basically it create a partition out of it. So when Spark read the file, it create a partition out of, let's say it read a file from this 4 location, and it create a partition out of it. How many partition would get create? Let's say generally in cluster, 120 MB is a default partition size. 128 MB is default partition size. So that way you will get the 40 partitions. So now your Spark job will get the 40 partitions of single file. So what this would do, it transfer few of the partition, let's say 10, 10, 10, and 10. 10 in each of the executor, it pass 10, 10 partition. So that way 40 partitions, right? And now each executor would start processing that data. Okay. Now coming to the next line, guys. When we are running second line, see my this partition is having 10, this VM is having 10 partition, this and this as well, right? What this VM would do, it apply the filter on top of partition it have. This VM also do the same, this and this also VM do the same. It apply the filter on the partition that they have. Once they apply filter, right, then our next operation is white transformation. Now guys, if you see white transformation, we are doing group by. Don't you think that when you are applying group by department, some of department might be available over here, right? Some of the department might be available here or anywhere, right? So 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 it need to club all data into the single place. Of course, right? If you wanted to do group by, you want, let's say I have a engineering department, right? If my engineering department data is available here and here, I may not get the right result, right? Because I'm doing group by operation. So my all data should be in specific place, specific executor. So it shuffle data from one place to another place. So might be some, let's say engineering data would go to the this VM, right? Then HR data would go to the this VM, right? From here to here, right? And and sales data might come to the this VM. So that's how data got shuffled from one VM to another VM. Each VM would shuffle their data. And shuffle is the guys, basically, I would say not basically, it's a resource sensitive operation. It take most of the resource when it do data shuffling, right? Now after data got grouped, guys, and of course for grouping I did a shuffle, right? Then I have, let's say, for engineering data is available over here, right? I can get all the engineering data at a one place, right? Or all the sales data at a one place. And then finally, when I do action, what happened? Now, see, because I need the average of salary, right? What it do? It would take data from all these node, okay? Because data is already grouped by, and we also apply this average operation. It would take all the data from this node and pass it back to the driver. So all these four, I'm just arrowing on a one node, but you have multiple nodes, right? Sorry, multiple processes. All these processes would give result back to your driver. This one, let me draw, otherwise it would be not clear to some of the guys. Okay, all these processes would give this data back to driver. right? So when driver get their data, it have two options. Either it can show that data on basically on a console, right? Or it can even sync. Now imagine guys, one of the scenario that if your data is too huge, okay, 5 GB is nothing, but you have petabyte of data, and if you wanted to, let's say, load, let's say, a petabyte of data, and you wanted to you apply the action on top of that, let's say show, right, or count any action on a driver, you might get the out of memory error over here, because your driver have only 20 GB of memory, right? So that thing you just need to know whenever you are doing any action in Spark. Okay, you have a couple of transformation and action. So this is what, when you do any action like show, count, I will show you what are all the actions, common actions and transformation in some time. But whenever you do any action, you need to make sure your driver have enough memory, otherwise you will get out of memory error. What alternative you can do guys? Whatever data that you got over here, right, you can even sync into another location. Let's say maybe from this cluster you wanted to store your data into S3, just giving one example, right? And that's completely possible. So you process, you collect data, and either you store into this cluster itself, because this cluster have huge capacity, right? Maybe you can create one table centralized, let's say, location in this cluster, and you can put your data files over there. That is a sync operation, right? Or you can store data externally as well. So that's completely depend on your use cases, right? Now, okay, let me get these things as well. Okay. So I talk about this, right? But I will just read, right? When you read the CSV file, right, using spark.read.csv, it automatically divide the file into the partitions, right? The Spark did that, do this job, and it process all these partitions parallelly, right? And for example, in our case, right, we had a 40 partitions, right? So what happened? And we have 4 executor and 12 cores in each executor, right? I have 4 executors and 12 cores in each executor. What is that meaning, guys? 12 into 4, that is 48. I have, since I have 48 cores, but my file partition size is only 40, right? So that way I can run full, I can process all the 40 partition at a one point of time, right? So this is how, guys, you will do the parallel processing in the Spark. So though you have 5 GB of file, but since you our in this cluster, we have configured the block size of, let's say, 128 MB, it would get the 40 partitions. Okay. And you can, and since you have asked for 4 executor and 12 cores, right? It's nothing but cores is nothing but the thread, right? So you have 48 threads available, and out of 40 threads will get these partitions and they will perform their job, right? Then I also talk about this transformation, right? Narrow, if you see, we apply some transformation in your PySpark code, some narrow transformation and some wide transformation. What is this, guys? Narrow transformation, data keep locally on a same executor, right? I told, right, when you apply filter, let's say you got one file and you apply, let's say, some, you are doing some filter on top of that, right? So data is not moving out of that executor. Let's say you got this 40 10 partition here, 10 here, 10 here, and 10 here, right? When you apply narrow transformation, data would not move out of this executor. But when you apply wide transformation, group by, right, for example, then data get moves across these nodes or executor, and that's how it costs more to your compute and cluster. What are example of transformation? Map and filter are the common example of transformation. Okay, and wide transformation is like group by, join, distinct. These are common wide transformation. And final action I told, right? Spark, right? So if you collect everything or count, if you took any action on driver and that action is a huge, not enough to get right memory, then you will get the out of memory error. what you can do in some cases, it's people mostly write data into the external storage. It could be DB storage, it could be the same cluster, it could be S3, right? And you can write whatever the format that you have, the Parquet, CSV, or anything for that matter, right? So now let me see. Okay. Now what I will before now, okay, guys, I talk about this Spark architecture. Okay. Now what I will do, we will create one Spark job and run it on a cluster, because I wanted to show you other detail. When you run your Spark job, what happened internally, right? Before moving, guys, do you have any question on current architecture diagram explanation? Okay. If no question, I will move to the next point. Okay. So now, okay, our Spark, we got a idea of how Spark processing work, okay, internally. Now let guys create one Spark processing on our basically Spark pool. I will run that piece of code there. And then when you are running your Spark job, right, it create the multiple stages and tasks. So let me see if I have something to talk before moving to cluster. Okay. Okay. Before moving to that, there, I will maybe quickly talk on these points first before going to the actual thing. So we talk about architecture and it's related to same only. Let me just make it in zoom mode. So guys, when the core component of, let's say, Spark master worker architecture, right? So first of all, component mention over here. Uh, Okay, and behavior. Cluster mode, I told you guys, right? Whatever the scenario I showed you, it's on a cluster mode. But if you go with the client mode, generally, when you are working in your company, right, you will always, as long as you are on production, right, or any QA UAT environment, you will be always work on a cluster mode only. For development purpose only, you do the client mode. Because imagine that you have cluster ready and you submit one Spark job, but that driver is running on your computer. And if your computer goes down, your application won't know, executors won't know where to respond, right? So your entire job would get killed. So people not generally prefer in this in not generally means people never prefer this in production mode or anywhere, right? So this is standard mode. People mostly go with the cluster mode, right? Then the next thing is, right, driver program, right? I showed you application master and driver are nothing but the same thing in a cluster mode, right? It run inside your cluster, right? Whereas in client mode, it run on your machine, client machine. That's what I was talking, right? And application master. In case of container, application master itself hosts the driver. So I told, right, driver and application master are the almost same in case of cluster mode, right? Whereas in basically client mode, it's run separate. Your application, this just you need to know if someone asks this question in interview. So the application run in a cluster, application master run in a cluster, whereas driver is on your local machine. That's how the difference is, guys. Right? You are seeing K8s and all these things. What are all these? We mostly talking about a YAN, but apart from YAN, we have the Mesos also one of the resource manager. The way YAN manage your resource with the help of resource manager and node manager. Mesos also is one of the basically resource manager, but it very less people use it. Okay, and Kubernetes also. Kubernetes and standalone. Standalone is nothing but your simple cluster you build, you set up on your local, right? And KTS means nothing but a Kubernetes cluster. So Kubernetes don't work with AM application manager and all. So that's completely different story. So mostly people use YARN only, right? Now executor creation, right? Executor got created basically. So in case of cluster mode, your YARN span the executor on a worker node, right? And here also application master or whatever your basically cluster provider is, it span the executor on your, it span all the processes in your executor. So that's how things, right? So who requested resource? So in case of cluster mode, your resource manager or driver, sorry, application master or driver is taking care of negotiation, whereas here driver is completely involved and your application manager negotiate the resources. Fault tolerance, if in case of cluster manager, guys, right? If driver crash, entire job fail, right? But AM can restart because see your application master is still running, right? So you will not get any error here. if your driver get failed, your application can stop entirely. So people, that's why prefer mostly cluster mode, right? So that you can still in case of, let's say, even if it's fail, you can restart and get the output things ready, right? And mostly people use this for production mode, and this is mostly for debugging mode. Okay, and these are all the example of, let's say, transformation and action, guys. When I was saying, right, there are a couple of transformation: map, filter, select, flat map, sample. We will be covering all these transformation in upcoming sessions. So these are all the example of narrow transformation. Narrow transformation means data not get shuffled. Okay, it just be there on that particular executor. Wide transformation, data got shuffled across executor. What are all the example? Group by, join, distinct, repartition, order by, union. All these are the wide transformation. Then actions: collect, count, show, save, take, for each. We will cover this in upcoming section. So these are all the actions, guys. Okay. Now, guys, see, I talk about driver manager, resource manager, right? Sorry, driver program, what is running, right? It's nothing but the program that to which executor respond. Then cluster manager, executor. These two things I just wanted to basically stage task and stages, RDD and DAC, right? And in memory computing, I told you what's happening, right? It's nothing but the process all data in memory. No IO happen. So now to learn this task stages and RDD and DAC scheduler, let create our. I will create some Spark job and I will show you how this task and stages look like. Right? When I'm explaining, guys, if you not got anything, just pause me. I would happy to answer. Okay. Now let me.
In interview, they will ask Spark architecture.
See, they will mostly ask the Spark architecture. Hadoop hardly people use nowadays. Okay,
Yes,
because
yes,
it's
right. It's a
yeah,
old one.
right.
And
Uh,
Databricks also come, I think, latest in.
yeah, see, Databricks is a what is Databricks? Databricks is nothing but the wrapper over the Spark. Who develop the Spark? They people combine and form their company Databricks. Okay,
Okay, I think
right.
it's acquired by Databricks Spark.
Right, right. So see, developer of Apache Spark, they
Mm-hmm.
create the Databricks only, right? So whatever you are seeing internal, these are the architecture perspective. Everything would
Okay,
happen into Databricks as it is. But Databricks provide you some more advanced operation. I will cover maybe in a later part of the curriculum. But yeah, it's
okay.
nothing but a wrapper over the Spark only. Okay. Now, guys, let me create some. Now I will be showing you task and stages. Okay, we create the Spark. We know how the thing got shuffle and how it got executed. But what happened exit actually when you submit your Spark job? I hope you can see my resource group screen.
Yes, yes.
Yeah. So now let me create Synapse workspace. Basically, I'll be getting Spark pool for that, and Spark will come up with the Synapse. So that's why we need to create this for Synapse workspace.
Synapse we can call ADF plus Databricks plus reporting, right? It's
Uh,
combination of
uh,
three.
yeah, see, Synapse provide you in Synapse, you can use ADF activity. It also help you to create Databricks. Let's say you have Databricks
Mm-hmm.
notebook. You can
Right.
even write notebook plus your data warehouse. So it's right.
And also reporting or
See, Synapse don't have, if I will show you workspace, Synapse workspace, it don't have Power BI there.
okay,
There is a Fabric come up basically now. Okay,
okay,
and what have Fabric have entire thing. It's have your ADF pipeline, it have your data warehouse, of course Databricks also it have, and it have your Power BI as well. So they,
okay.
so you see how they grow things, okay, how they gradually club things. They first of all started with ADF. They
Mhm.
combine they first of all started with ADF separately and data warehouse separately. Then they combine ADF plus data warehouse and show that as a Synapse analytic solution, Synapse solution, right?
Mhm.
Plus Databricks was also one of the activities, so we can club database and other things as well, right? And then
Okay,
now they combine data, basically ADF plus your data warehouse plus your Power BI and showing that as a Fabric solution,
okay.
right? Okay, elite resource group. Now workspace name I will give. I will just choose, I'm just giving the workspace name as elite workspace region as a US to use, right? US, East US. And then I will create the account name, right? I told you in earlier sessions as well, guys. If you wanted to create, let's say, Synapse workspace, you need to have one Gen 2 account. Either you can go separately and create there, or you can even create from here as well. Okay, I think elite Synapse is available. I will take that. So it will by default create one your Gen 2 data lake. Okay, and I will just create one folder over there, temporary. Okay. The moment you create these guys, this Synapse workspace is having storage blob data contributor role, right? So that this Synapse workspace can read write data from there. Now let me create the security. I will just choose. Okay, and just keep this thing for my reference. Okay, and I just give username, password, and I'm just going to the. I don't need a key encryption and all these things. I will go next, and I will just review and create. So this would create a Synapse workspace for me. When people ask, see, mostly people ask in interview, okay, have you worked on that? And maybe what you can do, guys, if you are very new to industry, right, you can explore this scenario. Maybe we can go with the simple scenario, right? You create a scenario, let's say dedicate pool or let's say Spark pool, right? And then you can, and you are doing some simple transformation. You read the CSV file from your storage account, process it, right? See how you can process the data, but you can gradually increase the complexity of it. You can think about the cross cloud, right? You can write a piece of code which will connect to the AWS S3, right, via code approach or low code approach, right? And of course people would ask then how you are storing this key. Then key vault and other things are the best places to store your keys. On top of that, I showed you, right, system assigned manager identity and user assigned manager identity. So you can explain that this way, that okay, you worked on all the possible things in terms of data ingestion, data processing, where we can sync data, right? You can sync data. So source side, okay, you have multiple options. Sync side also you have multiple options, right? You have databases, data lake, data warehouse system. You can also have, let's say, queuing mechanism. You have some data and you put that into the queue, right? Or SNS, for example, notification, basically Kafka or anything, right? The moment you put some data out there, there is another system which is reading that data. So that sort of things maybe you can go and try out by your own, and then you will get a more idea and clarity about the things. And of course, when you do hands-on, you will get some challenge, right? And because when you go to the interview, people would ask, okay, what are all the challenges that you face, technical challenges, right? So then that would help you to answer. Most of the time when you read a video, okay, because in video you get only the things in a flow, right? You not get error and all, but when you try, then you will get error, and from there only I think you would run better. Let it get create, guys. generally I don't create the things on the fly. Others, what happen, people sometimes not understand, okay, from here that suddenly come. So that's why if we do on that moment itself, people know that, okay, things are getting built from the scratch and how things work. Is anyone having anyone worked on Spark data frame and all? Because when yeah, someone was saying, I think.
No.
Okay, so we'll be covering some good session on Spark data processing, right? Because when it's come to the data processing, you can use a Spark as one of the language that's in demand, right? You can process in demand, right? People mostly use a Spark as a data processing language, right? So we'll be covering couple of session with the different transformation action. Though I just show you for in PPT today, but we'll be having some good sessions, multiple sessions on a Spark development, and you will maybe get chance to learn that from the scratch. Okay.
Okay.
Now we have some elite workspace created. Now guys, I just wanted to show you when if I just go to my resource group, because at the time of creation only I give this Gen2 account to get created. So that's why it create the Gen2 account directly for me. What I will do, I will just create, because I need to upload some file over here. Data management, storage container. Test is a, let's say one container I will create over here. So temp I already have. Okay, test is a container I am creating over here, and then add directory. Let's say, and
Do you change the DTU size here while uploading?
no, DTO size. See, I haven't yet created the basically dedicated pool, right?
Okay.
Right. When you create it, then you will be having option to which dedicated pool you wanted to use or change. That's how. Let me upload one file over here. So, okay, I have uploaded some simple employee.csv over here. Nothing but it have just some simple data just for our demo purpose. Okay. Now guys, let me go to workspace. So you see the SQL pool, right? It's a by default, whenever you are creating the Synapse workspace, it give you one serverless pool. Okay. When you create a dedicated pool, then it will ask you what dedicated pool you need, right? And DW units, right? How many DW units you need. The more you click on DW, it show you cost accordingly. So for demo purpose, always go with very less one, right? And post your usage, you can delete it. I will just discard these things. Okay. Now guys, I need to create a Spark pool here, right? Now you say guys, how things sorted with the help of, let's say, cloud. Earlier, okay, still node and other things are there, but internally you don't need to care about this Spark cluster and all, right? It by default create with some setting, just you can create your Spark cluster and see how many cores, right? How many GB of RAM, all these things is now configurable, and with some click you can create your Spark cluster. So I'm giving the name of the cluster nodes is I just use a memory optimize. I want a small cluster for my things, auto scale enable. Okay. And with minimum 3 node. So minimum 3 VMs and maximum 4 VMs. 10 VM you can take it as the same. Okay. And now I will just click on dynamic memory executor. In this simple demo, I don't want to enable the dynamic location executor. What it means, guys, it based on your data, right? I have very simple CSV file, but based on your data, it dynamically create more executors based on your usage. So for simple case, I know that I will be not having that much of load, so I will disable it. Otherwise, you can create it. Now let me create this Spark pool. Meanwhile, this Spark pool get create. Let me go to the Synapse notebook. and just put this piece of code over here. It's a very simple thing. I will explain. Let me first. So if I explain this, right, guys, first of all, I need some import, right? Because I know that I'm using some columns, specific things, and average, basically doing some aggregation. So that's why I import these things. My Spark pool got deployed meanwhile. I will attach my notebook to my Spark pool. Okay. What is my storage name? I just copied this guide. This is my storage name. In storage name, in storage account, I have one container with the name of test, right? And there I have one enc folder and csv file, right? Test is my container name, and then enc folder, there I am having csv file. What is next line, guys? This next line is nothing but how you read your, so your file is currently on a data lake, right? And data lake is a, if you wanted to read any file in data lake, this is how you need to give the location abfss, right? And then your container name, right? This is what your container name, your storage account, and then your path to data, right? So basically I'm giving the file location.
Any basic is required here to understand this Spark program, because we are not able to read or understand this.
Yeah, see, currently I'm showing you the stages and tasks, right? That's why these things are new. I told you, right? We'll be in next section, couple of sections. We'll be going through each and everything, right? Reading the CSV file. So currently I just directly type it, but we'll be doing things from the sketch, spark.read and CSV file, then apply some transformation and all these things we'll be doing in great detail.
Okay.
Right. So this is not something for to show what this code is about. This is main purpose is to show what is the stages and tasks. I showed you, right, other things, but I also wanted to talk on stages and tasks. So that's for that purpose I need to create these things. Otherwise, maybe you might not get what are all the stages and tasks and RDD and all those things, right? So this piece of code, maybe I will just quickly explain, because anyway I am going to cover all this thing in detail. So see, first of all, I'm giving file location. After giving file location, I need a Spark, because I'm doing data processing on a Spark, right? And I give the location of my file. I need my header from also, because in any file you have some header, right? Employee ID, employee name, those sort of things. CSV by default delimiter is comma, and we are just loading file, right? With some repartitioning and all. So those things I will cover in detail. Okay. And now once I got data frame, I am applying some transformation on top of that, narrow transformation, right? Which I showed you. It's the same thing, the whatever the code, piece of code. So guys, whatever the piece of code I was showing over here to you, right? In our diagram. Yeah. So whatever piece of code I was showing you guys over here, right? Same thing I am running over there, some narrow transformation and one wide transformation, and that's how I am that executing these things. Okay. So I'm sharing my elite workspace. Right, I apply some narrow transformation and white transformation, and I am doing action. Okay, now let me run these guys. I will be covering this code part in more detail, but I wanted to show you what is the stages and tasks. So it's starting now, Spark session. It would take few minutes. Because we got architecture, but what happened when you submit Spark job, right? When you run Spark job, how the Spark UI, because there might be some question, have you looked the Spark UI and all, right? And okay, architecture, but after execution, what happened? So those things, now I will show you. And maybe guys, maybe before next week, what you guys do, I will send you one document to install the Spark on your local, right? So that in upcoming section, whenever I am writing any piece of code one by one, you should know, okay, what we are doing, and you can also do those hands-on.
Instead of installing Spark, or can we directly log in on Databricks?
Yeah, Databricks also we can do, or even Synapse also can do. But since our main purpose is to learn the Spark, right? We not need to go to Databricks, right? Databricks will come in later stage.
Okay.
Yeah.
Okay.
Because ID is the best thing. I have the PyCharm things ready on PyCharm, because when you do practice, right? Let's say you do practice, right? You cannot go on database every time. It would compute you, and it would give more cost, and that would be as a constant when you are learning, right? So if you install the things on your local, you can get a Spark job. You can apply all the transformation action, and you can get good control on data frames and other things that
Okay.
way. So when you are submitting job, it takes some time. So that's why we need just to wait for this. And post running, guys, you should see some, if it succeed, then you should see some Spark UI. I will show you Spark UI. What is Spark UI is. It show the cluster is ready. Now I think it's doing some processing. Okay, it's running now, I think. Okay, started the process. It's a simple, guys, operation now we are doing. On my file, I just take the data with the salary greater than 50,000, and then I am applying the group by based on a department and just taking average salary. Okay, my job execute. We, as of now, we don't need to get into the code part of it. I will explain codes in a later section. But main thing is, now let's click on Open Spark UI. Guys, when I submit when I submit the job, it show and click on Spark UI. It opens. This is your Spark UI, right? When you run your Spark program, right, in actual production environment or any other environment, right? You need to at least have some understanding of what internally happen when you submit a Spark job, when you run any Spark command, even on a notebook as well. So, guys, if you see in my code, there is some job. The moment, let's say, I do any action, okay, I told you, right, there are a couple of transformation actions happen in Spark, right? I told you here. In Spark, we have this transformation and action, right? The moment you do action, it will create the new job for you. The moment you create action, so here, let's say I did one action, right? Show is one of the action, and reading CSV file is also one of the action. So that's why it trigger to job number one and job number two. I can show you those things on a UI. See, you have job number one and job number two. These you can ignore because it skipped those things. Okay. So I have two jobs. Now we have narrow transformation and wide transformation, guys, right? So when you do narrow transformation, so the way Spark work in lazy manner, what is the meaning of that? You read, of course, okay, this is one job, right? But once this job got created, on a second job, what you did, you apply some filter on top of that data, right? Then you do group by, and so until you don't do anything, it will not create any action. It will create only action when you do this operation. So that's how you got two action in your entire code, and you can see this two job. For each action there is one job, yeah, it creates, right? And you can see this two job over here. Let me use a marker, right? This one job and this one job. These you can ignore, these are just skipped one. Okay, now guys, stages. Let's talk about the stages. What are the stages? Spark internally divide your entire processing into the jobs and stages and tasks, guys. we talk about a job. Now let's talk about the stages. Now what happened in stage? Each job will have one stage, of course, plus the moment you do any white transformation, it will get another stage. So that way, since in each job, I told you that in each job you must have at least one stage. So this job will be having one stage, this job will be having one stage, right? And then when you are doing this operation, right? Because group by is the moment you do white transformation, it will get another stage, right? So job have one stage. The moment you do group by operation, that will also create one stage, right? And other part, whatever the left part, that would also come in another stage. So that's how here you see you got a 4 stages, right? If I click on any one of the stage, you should see task, right? So here is your task ID. Task ID 0, right? That way you have it have one task and that task ID 0. If I just click once more on a stage and show you another task, click on that particular stage detail, it will show task ID 1, right? So for each in Spark, for each action, it will create the job. Your job is split into stages of your job is split into multiple stages and tasks based on your white transformation. Okay, and also the amount of partition that you have. So now let me show this in diagram to explain you. In our case, guys, we create the two job, right? And for each job, we are having some, let's say if I just click on stages, I told you, right, how these 4 stages come, because I have why these 4 stages come, because my first job create first stage, my last job create also one stage, right? Then the moment I do group by, that also create one stage, and the rest of the things also create as a one stage. So this is how I got the 4 stages, guys. And for each stage, you can have one or more tasks. How it's depend? It's depend on the number of partitions that you are having in your stage. Okay. If I show you diagrammatically these things, think. Guys, can you see my drawing against?
Yes.
Guys, can you just give confirmation to me?
Yes, we are able to.
Okay. So see, your entire Spark code, whatever you are writing, right? It's splitted. I just give you that what happened internally in Spark UI, right? But you should know internal perspective, your entire Spark code gets split into jobs. How many jobs? It's depend on your actions. The number of action that you will call, those number of jobs it would get it create. Now for each job, you can have one or multiple stages, right? And for each stage, you can have one or multiple tasks. So that's how internally your entire execution gets split. Each action result into one job. Each white transformation result into the separate stage. Okay, and every stage execute in parallel depending on number of determined partitions. So how many partition that it having, based on that it would run, right? And based on a partition in stages, Spark will create the task for each partition. So let's say you have 10 partition, right? So Spark will create the 10 tasks to execute those 10 partitions. So this is how, guys, just at least from interest perspective, you need to know that how these things happen internally. Now, if I will again show you one more thing. Okay. So we just talk about this narrow, wide, and this we talk about. Okay, this part, right? We talk about the stages and tasks now, right? Because whenever you are running any piece of Spark job, it would divide into the stages and tasks, right? Executor nothing but I told you that when you are earlier I showed you right in draw that okay, these are all the executor. Your driver would allocate the 4 executor and run your piece of code over there, right? Cluster manager is nothing but the, or resource manager is nothing but the main resource negotiator, and your driver program who launch that process executor in your cluster, right? And now we talk about this task and stages as well. Now I will show you DAC execution. See, when you are doing transformation, right? If I just show you once again, go once again in my code. Okay, so when I'm showing the, see, when you are doing any transformation, right? Spark, unless until you don't take action, Spark Spark create a DAG out of it, right? It's called direct acyclic graph. It create a DAG out of it, right? I will cover a DAG in more detail in upcoming section, but it generate a DAG, right? And the moment you apply any action, then it generates some logical and physical plan out of it to get the best physical plan to execute your job. So I will just show you this, how that DAG look like when you go to the Spark UI, right? When you go to the job, let's say, let's click on a first job. You can see your job. Okay, click here and just click on DAG. So you see, in first, this is what the DAG, you don't need to know this detail, but at least I'm giving you this in very detail so that you should know all these things. But at least, and you not even need to know that what this DAG is doing, but at least some getting some basic sense out of it, right? You are reading some data. That's what you are seeing over here, right? You are scanning some text and other things, right? This is what one DAG. I will show you now another DAG as well. If I just click on this DAG visualizer, you scan the CSV, now it's doing exchange. What is exchange, guys? The moment you do shuffle operation, right? Data got shuffled from one, because in your code, you have used this shuffle operation, group by, right? The moment you do any shuffle operation, it do exchange. And that's how you are seeing this in DAG. So to summarize, when you create the Spark job, okay, it create, basically when you launch any Spark submit button or you run your piece of code in a Spark cluster, it create jobs based on the number of action that you perform. Okay. Now for each job, there can be one or multiple stages, right? And for each stage, there can be one or multiple tasks based on your data set, right? And the partitions and all. Okay. RDD I will cover in next maybe session, because when we will be doing hands-on, I will show you how this RDD look like. Okay. And I told you, right, this entire processing is in memory processing. We are doing entire, when we are loading data, right? Applying group by, doing transformation, doing filter, this entire thing happen in memory. So Spark is in memory processing, no IO involved over here, unless until you explicitly specified it. Let me see what, okay. IDD, another thing I will cover in next maybe session, guys. Let me see if something I haven't yet covered over here. Okay. I think from the Spark architecture perspective, we cover entire thing. Second week 3 session. Let me open this right tab. Okay. Yeah. Yes. right? Guys, any question you have, whatever we learn at a high level, right? These things I try to give this in more detail. Generally, you will not see this much of detail, right? Details things, how the piece of code get executed across all the cluster. Maybe you need to go, maybe some of you might be hearing this first time, right? So I would encourage you to guys to go into more detail and read this session so that you can understand more out of it. So any question, guys?
No. No question for today.
Okay. Okay, maybe taking it as a no question, right? 1 second. Okay. So what we'll do, guys, now in upcoming session, I will show you the IDD in all this part, right? So what is the data frame, right? That data frame is nothing get boiled down to the IDD itself. I will create one of the IDD, and then in upcoming in next section, maybe what I will do, we will do some more on a coding side, right? How to create a data frame and how to apply, can we write the SQL into data frame, right? If at all possible, what are all the different transformations and actions we are having, and we'll create couple of use cases so that you guys can get more comfortable on data frame side, guys.
Okay. So
Yep.
before doing starting like a Spark coding, do you need any Python basic?
Very basic Python would required.
Okay.
Yeah. Even see, I would say this, even if you have a very less knowledge on SQL, and I can show you the, okay, because see, if you would ask anyone that, okay, what are the query that I showed you, right? Select filter, select these and these column dot filter, right? And method, and then what column you wanted to apply filter, right? Let me show you
Yeah.
instead of just.
SQL knowledge we have. Currently also we are working on SQL.
So yeah, I was just talking this thing. See, right? So you see, guys, if you are seeing my notebook, I think yes, you are seeing my notebook. See, select, right? The filter. These are nothing but the method. So SQL is the best way to deal with data, but what data frame developer did, okay, they create some method for you. Instead of in SQL, what you do, you apply where condition, right? So it's nothing but a filter over here, right? And on what column you apply filter and those sort of things. Then you have the group by clause in SQL, right? The same way on this data, right? You are applying group by. So it's a basically they have created a method so that you can, if you don't need to write big SQL, you can split your entire big SQL into small chunk of data frame. So yeah, if you are even basic knowledge of SQL, this would go easily. And yeah, and already in all these things, maybe I will cover what a resilient data frame distribution, all right? Because entire thing, whatever data frame that you are seeing over here, are everything would get into the convert into the IDD. And I will cover in more detail something like I told you, just give you one hint, right? When DAG got created, right? What happened? Because when DAG got created, there is a DAG scheduler and other things are also there. So maybe in next session I will cover. First of all, I will cover these things and then we'll go to the hands-on part of coding. Any question for me, guys? The interview perspective or anything you wanted to know?
No problem.
Okay. Okay, then we'll conclude today's session, guys. We'll see you tomorrow. We'll first cover tomorrow some basics of this other things that IDD and other things, right? I just wanted to give a brief because ultimately this all the data frame will boils down to the IDD. How Spark, because when you are running this piece of code, right? If your code is optimized, well and good, but if your code is not optimized, how Spark create the plans, right? To logical and physical plan, and then choose best plan and then process data. So I will just give some information around that, okay? And then we can do the hands-on activity tomorrow on the coding part. This I will be getting how to get the we will be learning how to get the Spark data frame, how to apply this narrow transformation and wide transformation. We'll show these details. All right. Okay, then guys, if no more question, we can conclude today's call, right? Meanwhile, if you, while listening to recording, if you got anything, just ping me. We are happy to help. All right. Thank you very much.
Thank you.
Thank you so
Thanks.
much.
Thanks.